We'll start it here. All right. I'm Olivia Roseberry, and I had the presentation on what is dye and the chemistry behind color. We know that yellow is a vibrant, rich color that catches the attention of medium and long wavelength cones that reside in our eyes. But we know how we see color, but what is color? From ancient colors made from clays and toxic colors used in paintings to today's synthetic dyes, the chemistry behind color is truly fascinating. In the very early years during the Neolithic time period, colors occurred naturally by, by the use of clay. For example, we had colors red, yellow, brown, and like dirt brown, I guess. My internet's unstable. Hope this still works. Some clays can be found that is loaded with iron. These iron-filled clays can have names like hematite and limonite. These clays can be ground into a powder. These are called ochres. Yellow ochre, which is driven from limonite, has a chemical composition of iron 2, oxygen 3 with a molecule of water. Red ochre, hematite, is basically ferric oxide, which is just 2 irons and 3 oxygens. The picture over here is a picture of basically the Lewis dot structure between iron and oxygen, which is basically the hematite. People would roast the yellow clay over fire to push out the water and turn the yellow ochre to red ochre. Moving on further along, we have arsenic. Arsenic was used in green paintings and color. Sheila's green was made in 1775, and in 1814, Emerald's green was made. It was basically a dry from Sheila's green, but it was a little bit more toxic and it held its green longer. They made these greens by heating sodium bicarbonate, which is basically baking soda, and adding arsenious oxide. The addition of arsenic mixed with copper gave this green its vibrant color that wouldn't fade. The chemical equation for green is arsenic, copper, hydrogen, 3 oxygen. It was a very toxic color back in the day, and there was talks that Napoleon died because he loved the color green and he painted his walls the color of green. And today we have synthetic dyes. One of the most popular dyes that we have made is Vanta Black. It is the most blackest of the blacks. It was hard to make. It was made in 2014. It absorbs 99.96% of light. It consists of nanocarbon tubes. These tubes of carbon are made within a lab. Basically, they are made by these nanotubes are placed on sheets of aluminum in an attempt to grow these carbon tubes. Normally, this act is impossible due to oxide layer on top of the aluminum. The oxide layer is removed by a saltwater mixture. Baked in an oven with no oxygen and a carbon source, these carbon tubes are able to grow right on the aluminum. And this is my works cited page, but in the past we have created several different ways. The earth naturally gives color. We have also mixed different natural things together like copper and arsenic to give a bright green. Vanta Black and neon colors are made, thus giving us synthetic dyes. I could go into information about why, going back to the arsenic, because I actually just found this information like an hour ago, but arsenic enters the body through absorption through the skin. The liver detoxifies through adding a menthol group, which is carbon and three hydrogens. Eventually, arsenic will become too much and the liver will fail to detoxify. Arsenic will become concentrated and keratin rich, so basically like hair, nails, and stuff. That's what this link down here at the bottom was. Found it on a YouTube channel. Spent like hours trying to figure out where to get this information from. But anyways, any questions?
No. Sounds good.
No, thanks. Thanks. All right, thanks for joining. I'm gonna end this recording though.